Welcome back to Tales of Chemistry. Today, let us learn what is Gay-Lussac's law. According to Gay-Lussac's law, when gases react, that means this law is applicable only to gases. They do so, they react in volumes. So, the reacting volumes of the gases are considered, not the weight of the gases, the volume of gases bears a simple whole number ratio. So, whole number ratio to one another, meaning between the reactants and between the products, provided all of them are gases. Provided, the reactants, the products, all of them are gases under similar conditions of temperature and pressure. So if the question is define Gay-Lussac's law, the whole thing has to be written as it is. When gases react, they do so in volumes which bears a simple whole number ratio to one another and to the volume of the products if gaseous, provided the temperature and pressure remains constant. Now, to understand Lussac's law, let us take an example. Suppose hydrogen combines with chlorine to give us HCl. According to Gay-Lussac's law, if 1 liter of hydrogen is taken, then you need 1 liter of chlorine and the result will be 2 liters of HCl. If X liters of hydrogen is taken, then you will need X liters of chlorine and 2X liters of HCl will be the product. Similarly, if you consider 2H2 plus O2 gives you 2H2O formation of water vapor, then according to Lussac's law, 2x volumes of hydrogen requires x volumes of oxygen to give you 2x liters of water. Meaning, suppose if I have taken 50 milliliters of hydrogen, then I will need 25 milliliters of oxygen and the product will again be 50 milliliters of water vapor, provided you are taking the calculations under similar conditions of temperature and pressure. Now, let's solve some examples. Number 1, nitrogen reacts with hydrogen to give you ammonia. So, the balanced equation will be given N2 plus 3H2 gives you 2NH3. Question is to calculate the volume of ammonia if volume of hydrogen taken is 6 liters. Very simple question. Nitrogen combines with hydrogen to form ammonia. Calculate the volume of ammonia if the volume of hydrogen is 6 liter. So here we will write according to Lussac's law, Gay-Lussac's law, X volumes of nitrogen requires 3x volumes of hydrogen and you will be getting 2x volume of ammonia. And what is given here? It's given volume of hydrogen is 6 liter. That is 3x is equal to 6 liter. X is equal to 2 liter. Therefore, volume of ammonia is equal to 2x, which is 2 into 2, 4 liter. So your final answer, do not leave it as 2x is equal to 4 liter, but write volume of ammonia is equal to 2x, and that is here 2 into 2, 4 liters. Final answer, 4 liters of ammonia. Moving on to the next question. 2,500 centimeter cube of oxygen, cc of oxygen, was burnt. This was burnt with 600 cc of ethane. Equation will be given. Calculate the volume of unused oxygen. Calculate the volume of unused oxygen and the volume of carbon dioxide formed. So first of all, what we need is the balanced equation. Ethane, C2H6, it's burnt in oxygen to give you carbon dioxide and water. Any hydrocarbon on burning completely in oxygen gives you carbon dioxide and water. Okay, so C2H6 plus O2. So I must write 6 water, 2 C2H6 to 4 CO2. Okay, and now the number of oxygens, 8 plus 6, 14, 7 oxygens. Now, according to Lussac's law, the ratio is 2x plus 7x gives you 4x plus 6x. Okay. Now, it's given volume of oxygen is 2,500 centimeter cube. Volume of ethane is 600 centimeter cube. Should I now take 2x is equal to 60 because the number corresponding to ethane is 2x? Or should I take 7x is equal to 2,500? When we read the question, it's mentioned calculate the volume of unused oxygen, which means it's clearly mentioned that oxygen is taken in extra. Oxygen, 2,500 centimeter of cube of oxygen is not used completely, which means 7x is not equal to 2,500. Instead, 2x is equal to 600, just because they have mentioned calculate the volume of unused oxygen. We decided that 2x is equal to 600 cc, x is equal to 300 cc. Then, to calculate the unused oxygen, we need to know volume of oxygen used is equal to 7x. 7 into 300, that is 2,100 centimeter cube. Therefore, first answer, volume of unused oxygen. Volume of unused oxygen is equal to given volume 2,500 minus 2,100 cc, that is 400 cc. Another part of this question was to find the volume of carbon dioxide. Carbon dioxide is 4x. So, volume of carbon dioxide is 4x, which is 4 into 300, that is 1,200 centimeter cube. 2 questions were asked. Each answer will generally be of 1 mark. So, unused oxygen 400 cc, 1 mark. Volume of carbon dioxide produced 4x, 1,200 cc, another 1 mark. Question number 3. 20 ml each of oxygen and hydrogen and 10 ml of carbon monoxide are exploded in an enclosure. Okay, what will be the volume composition of the mixture of gases? So, you should calculate the volume composition if they, meaning the reactants and the products, if they, the products basically, if they are cooled to a room temperature. Each sum that we are doing today is different. Okay. Now, this cooled to room temperature has a meaning. Now, first of all, let us write the equation. Point number 1, there are two equations that are taking place, or two reactions that are taking place here. One, you are exploding hydrogen with oxygen. Also, you are exploding carbon monoxide with oxygen. Hydrogen on explosion with oxygen gives you water as per this equation, and carbon monoxide will give you carbon dioxide. It is mentioned that, okay, in the first equation, burning of hydrogen, 20 ml of hydrogen is taken. So here 2x is 20 ml, x is equal to 10 ml. What will be the volume composition? All right. So let us see volume of oxygen used, consumed is equal to, this is 2x, this is x, this is 2x. So volume of oxygen consumed is equal to x, which is equal to 10 ml. How much oxygen was given to you? 20 ml was given, out of which you now finished 10 ml. Okay, then moving on again, 10 ml of carbon monoxide was also taken. So the second half, 2x is 10 ml because 10 ml of carbon monoxide is taken. So 2x is 10 ml and x therefore is 5 ml. Volume of oxygen used, consumed in the second half is just 5 ml. Now, what is the total volume of oxygen consumed or used? That is 10 plus 5, 15 ml. What will be the volume of oxygen remaining? So, unused volume of oxygen is whatever is given, 20 minus 15, that is equal to 5 ml. So, you got one of your answers, that is the resultant composition will be 5 ml of oxygen along with other products. Now, first equation, what is the product? Water vapor. But it's mentioned that the products are cooled to room temperature. When you cool water vapor to room temperature, it will convert to liquid water. And Gay-Lussac's law cannot be applied to any liquid, which means we do not write volume of water here. Reason? Lussac's law can be applied only to gases, and on cooling the resultant mixture, your water vapor will become liquid water. Okay, moving on again. Second half, carbon dioxide is the product. Carbon dioxide will be, on cooling, will be in the gaseous state itself. So let us figure out that. 2x is to be calculated. X is 5 ml. Volume of carbon dioxide is 2x. 2 into 5, that is 10 ml. Now, the final answer has to be written down separately, stating the resultant composition. The resultant composition is equal to 5 ml of unused oxygen and 10 ml of carbon dioxide. This is your final answer. Now, moving to the next question. 224 decimeter cube, sorry, centimeter cube itself was given in the question anyway, of ammonia undergoes oxidation in presence of catalyst, which is mentioned, to give nitric oxide and water vapor. To give nitric oxide and water vapor. Calculate the volume of oxygen required. Calculate the volume of oxygen required for this reaction. All volumes measured at room temperature and pressure. Okay, so 224 dm cube of ammonia undergoes oxidation. So the equation is 4NH3 plus 5O2 in presence of platinum gives you, okay, in presence of platinum gives us NO plus, okay, 4NO plus 6H2O. 4NO plus 6H2O. Now, in this, 4x, 5x, 4x, 6x. This is the ratio according to Gay-Lussac's law. And it is given, only one quantity is given to you, that is 224 dm cube of ammonia is taken, which means given 4x is 224 dm cube. Okay, then X will be 224 by 4 dm cube. So whatever it is, you can leave it the same way, or you can divide it 4 by 4. That is equal to 56 dm cube. But what's the question? Calculate the volume of oxygen required. So your answer is volume of oxygen required. Volume of oxygen required is equal to 5x, which is 5 into 56, which is 280, whatever is the unit. This much of oxygen is required. 280 dm cube of oxygen is required for the reaction. Moving on, the next one. Acetylene burns in air. Acetylene burns in air forming carbon dioxide and water vapor. Calculate the volume of air required. Okay, this question is again different from all the other questions. Calculate Okay, the volume of air required to completely burn 50 centimeter cube of acetylene. So let me write the equation for you now. Acetylene is C2H2 plus O2 gives you CO2 plus H2O. Then now the balanced equation is 4CO2 plus 2H2O are the products, and 8 plus 2, 10, 5O2. According to Lussac's law, 2x acetylene, 5x oxygen, these two react to give you 4x carbon dioxide and 2x of water. Okay, question is to calculate the volume of air, not oxygen. All right, so what is given? What is given to us is 2x is equal to 50 cm cube. So x is equal to 25 centimeter cube. So first of all, let us check how much volume of oxygen is needed. Volume of oxygen required is 5x, which is 5 into 25. 5 into 25, 125 centimeter cube. But that's not the question which is asked here. The question is calculate the volume of air required to burn. So air contains 20%. 20% of air is oxygen. Okay, this will be given in the question, don't worry. 20% of air is oxygen. So 20% of X, okay, I'm calculating air as X, or let's write 20% of air is 125 centimeter cube. Okay, so volume of air, how do we calculate? Let's do it here. 20 by 100 of X is 125. Therefore, X is 125 into 100 by 20. So we just need to calculate this. This will be 625 centimeter cube, cc. Okay, so that is the final answer. Volume of air is 125 into 100 by 20, which is 625 centimeter cube. So that was the question. Next one is on igniting a mixture of acetylene and oxygen. Okay, so let me write the question. On igniting a mixture of acetylene and oxygen, 200 centimeter cube of 200 centimeter cube of carbon dioxide is formed. Okay, so here the volume of reactants are not given to you, but the volume of the product is given. Calculate the volume of reactants. Calculate the volume of the reactants, that is acetylene and oxygen. So equation is 2C2H2 plus 5O2 gives you 4CO2 plus 2H2O. Now, it is told to us that volume of carbon dioxide is 200 centimeter cube. According to Lussac's law, the reaction here is in the ratio 2x, okay, plus 5x gives you 4x and 2x. So 2x volume of acetylene react with 5x volume of oxygen to give you 4x volume of carbon dioxide and 2x volume of water. It's given volume of carbon dioxide is 200, which means 4x is 200 and x is 50 centimeter cube. Therefore, volume of acetylene, which is 2x, is 2 into 50, that is 100 centimeter cube. Similarly, volume of oxygen, 5x, is 5 into 50, that is 250 centimeter cube. So that was also a simple question, even when volume of reactants were not given, but only the volume of the product was given. Now, the next question. This is again different. 100 cc of each water gas and oxygen. 100 cc of each water gas and oxygen are ignited and the resultant mixture of gases cooled to room temperature. Calculate the resultant composition. So the question is to calculate the resultant composition. 100 cc of each water gas and oxygen are ignited. Well, water gas is a mixture of carbon monoxide and hydrogen. So that is the first information that we needed to have here. Water gas is a mixture of carbon monoxide and hydrogen. So you are igniting carbon monoxide with oxygen, similarly igniting hydrogen with oxygen. So here what happens is, okay, here 2CO plus O2 gives you 2CO2 and 2H2 plus O2 gives you 2H2O. Then the next point here is 2x as per Lussac's law requires x volumes of oxygen to produce 2x volumes of carbon dioxide. Similarly, 2x volume of hydrogen requires x volume of oxygen to give you 2x volume of water vapor. Now, 100 cc of water gas and oxygen. Volume of water gas, okay? So it is told to us volume of water gas is 100 cc, 100 cubic centimeter, which means CO plus H2, the volume is 100. Water gas is a 1:1 mixture. of carbon monoxide and hydrogen. Therefore, volume of carbon monoxide will be 50 cc and volume of hydrogen will also be equal to 50 cc. Volume of carbon monoxide is 50, volume of hydrogen is equal to 50. So, moving on now, here given 2x is 50, therefore x is 25 cc. What's the question? Resultant composition. To know the resultant composition, volume of oxygen to be calculated. Volume of oxygen used up is x, which is equal to 25 cc. Okay, and the product volume of carbon dioxide is 2x, which is again 50 cc. Coming to the right hand side, it is given 2x is equal to 50 even here and x is 25. Therefore, volume of oxygen used is x, that is 25 cc. Volume of water, I don't have to write because it is told the resultant mixture is cooled to room temperature. So my task now is to check how much volume of oxygen is consumed and therefore how much is remaining. So volume of oxygen consumed is equal to 25 plus 25, that is 50 cc. Volume of oxygen unused or remaining is 100, which was given initially, minus 50. So 100 minus 50 is once again 50 cc. What's your question? Resultant composition. So your answer here is the resultant composition. The resultant composition is equal to 50 cc of unused oxygen and 50 cc of carbon dioxide. 50 cc of carbon dioxide. I hope you have understood Lussac's law in detail now. Stay tuned for more videos. Thank you.